Hello, everyone. Thank you for joining me. This is Psych 18 Research Methods, and today we're going to talk about Chapter 9 Factorial Designs. Okay, so what we're going to do today is talk about what factors and levels are, describe factorial design characteristics, very importantly, help you understand the meaning of factorial notation, differentiate from effects, the main effects, interaction effects, and simple effects, discuss reasons to use a factorial design and how you can tell from an article whether or not the study was a factorial design. So when we talk about factors in factorial design, what we're looking at are the potential causes. Remember, we're here for psychology, so we're usually studying some sort of psychological construct. And because people are very complex, we're often looking at more than one independent variable. So with a factorial design, you're not just looking at one potential cause, you're looking at least two or more causes. A level is how many values each factor has. So let's say you're thinking about the effect of caffeine on someone's alertness in driving. Well, we think it's not only caffeine, it's the time of day they're driving, right? So the two factors then would be amount of caffeine they're drinking, and then the second would be the time of day. So levels has to do with the quantity of a specific factor. So if we're thinking about caffeine, maybe one level is no caffeine, a second level could be 2 cups of coffee, and then a third level might be 4 cups of coffee. So it all has to do with caffeine. It's sort of the quantity that's involved with that factor. A factorial design is a study that simply includes more than one independent variable. So what's important to know is that any of the designs we talked about, non-experimental, experimental, quasi-experimental, those can be conducted in a factorial design. As long as you're looking at more than one independent variable, that becomes a factorial design. So in your proposal, if you want to study more than one independent variable, you need to identify it as a factorial design experiment or factorial design survey, that kind of idea. And that way I know that you understand that a factorial design involves more than one independent variable. So how does it look? Well, very often we're looking at either 2x2 or 2x3 factorial designs. We do not want to get more complicated than that, because the more levels, the more factors we're looking at, the more complex the analysis, the more participants you're going to need. So in a factorial design table on the left, right, you have the independent variable 1, IV1, right to the right of the 2x2 sign. And then you simply have IV1, level 1, IV1, level 2. And then you put the information about the second factor over on the side. So IV2, level 1, and IV2, level 2. We want to make sure that what we're doing here is we're showing the intersection here, the dependent variable. How does the dependent variable value turn out when you mix IV1 level 1 and IV2 level 1? Then you're looking at what is the value when you have IV1 level 1 and IV2 level 2. So you're trying each combination, right? So the combinations, the conditions are multiplied depending on how many factors you have. So for example, in the example I was saying, let's say we're thinking about driving ability, right? The first factor, IV1, might be time of day, whether somebody's driving in the morning or in the afternoon. Second factor that we think affects driving ability is caffeine. So the two levels are no caffeine and some caffeine. So some caffeine should be operationalized, as in how many cups of coffee. When we're looking at the combinations, right, let's look at IV1 is time of day. So in the morning, if somebody has some caffeine, how well do they drive? That's in the top left quadrant. In the morning, if somebody has no caffeine, how do they drive? So that is in the bottom left quadrant. Then we see if somebody's in the afternoon and they have some caffeine, what's their driving ability? That's in the top right quadrant. And then if they have, in the afternoon and they have no caffeine, how is their driving ability? That's in the bottom right quadrant. So this is how we put in the information when it's a factorial design. Sometimes you might have a 3x2 factorial design, in which case there are three independent variables. Two independent variables, and one of them has 3 levels and the other one has 2 levels. So an example of a 3x2 is, instead of just morning, afternoon, we could have morning, afternoon, and evening, and there would be your 3 conditions. And then your independent variable 2 could still be no caffeine and some caffeine. So this adds another layer of complexity when we are studying any kind of psychological construct. So in terms of notation, right, this is really important to understand. The number of independent variables is going to be represented by how many you have in front of you. So if it's 2x2, those are 2 independent variables. If it's 2x2x3, those are 3 independent variables, right? The order of the independent variables doesn't matter. That's up to the researcher. Usually they list it in order of importance. So the number of independent variables is indicated by how many factors are listed, right? Blank by blank. That tells you there are 2. If you see blank by blank by blank, then there are 3 independent variables. The actual number that you're reading tells you how many levels are in each independent variable. So here's our example. If we have a study and it's a 2x3 factorial design, then we know there are 2 independent variables because we count how many there are, right? There are 2 of them. The number, the value in it tells us the number of levels. So the first independent variable has 2 levels. The second independent variable has 3 levels. If we want to know how many conditions there are, we multiply those values. 2 times 3 equals 6. If we want to know how many levels there are, we add the values. Because the first one has 2, the second one has 3, 2 plus 3 equals 5. So make sure you understand the difference between a level and a condition. A condition combines the independent variables, right? So you have, the reason there are 6 conditions for that example I gave is there's a condition of morning plus no caffeine. That's one condition. Morning plus some caffeine. That's the second condition. Afternoon with no caffeine. That's the third condition. Afternoon with some caffeine. That's the fourth condition. Evening with no caffeine. That's the fifth condition. And evening with some caffeine. That's the sixth condition. That's what we mean by conditions. It is that combination of the 2 independent variables together. That's why you multiply the factors when you're trying to find out how many conditions. But if you just want to know how many levels there are, you simply add the numbers. Okay.
Professor, can we go back to the notation slide? Sorry, the one before.
This one?
Yes, okay. I was just finishing reading it and I was just I was seeing how you were putting the examples.
Does it make sense?
Yes, it does. I'm writing like levels equals add, and then conclusions, right? Equals multiplication.
Condition.
Condition, sorry.
Yeah. Okay, and I will, I can post a PDF of this as well. I thought I had it in, but I can post it.
No worries, thank you.
Yeah, no worries. So as you can see, so total number of conditions, remember you multiply. For total number of levels, you simply add. Any other questions? Okay. The other decision we have to make when we're doing a factorial design is whether we're going to do it as a between subjects or within subjects design. Remember that between subjects means that we are comparing 2 different groups. So we have different groups involved. Within subjects, it's the same people in the conditions. So when we're talking about a factorial design, it becomes even more complicated because you have to decide it for each independent variable separately. So, for example, if we have a fully between subjects factorial design, that means all the independent variables are manipulated independent groups. There are different people in every single condition. We would do this if the variables that we have are going to have carryover effects, that we cannot actually do a within subjects component. So between subjects factorial design, you have different people in every single condition. With a fully within subjects factorial design, you have the same people in every single condition. So for example, the one I talked about in terms of caffeine and driving, you might want to use it with different people because you might think, oh, in the some caffeine level, that's going to affect them morning. You know, you can't have the same people morning, afternoon, and evening on the same, if you wanted it all done in the same day, because the caffeine they drank in the morning may still affect them in the afternoon, and that caffeine may still affect them in the evening. So you would have it would be influenced, right? If you wanted it to be, if you wanted it in one day, it would not make sense to do it as a within subjects. There would be confounding because of the carryover effects of the caffeine. If you were able to separate it out, then you could do a within subjects with all the same people, but you would probably have it in 3 separate days. So one day you would test them all in the morning. Second day, you would test them all in the afternoon. And the third day, you would test them all in the evening, but they're all the same people. If you're short for time, you do it between subjects because one time you can do all the different conditions, right? If you want to eliminate the possibility of, individual differences and you have a little bit more time, then you conduct it as a within subjects factorial design. Finally, you have what we call a mixed factorial design, where one independent variable is treated as between subjects, and then the second one is treated as within subjects. When would you do this? Well, let's say one of the independent variables is a characteristic, a non-manipulated independent variable like someone's sex, like male or female. You can't manipulate that, so you have to treat that independent variable as a between subjects component. Then the other one, maybe it could be, driving ability. That one in the morning, afternoon, evening, that one you can leave as within subjects. So you would test your participants who are male, morning, afternoon, evening. You would test your participants who are female, morning, afternoon, evening. So that's an example of a mixed factorial design. So as I mentioned, a lot of times you might do a mixed factorial design if one of the independent variables you're interested in cannot ethically be manipulated. So characteristics like somebody's age, if you're talking about age groups, you won't have the same people who would be adolescents, early adults, and seniors, right? You can't do that. So that by default has to be between subjects, that kind of variable, or height, or, gender identification, that kind of idea. So this gives you an idea when you're trying to design your study. This is why it's important to think about your participants. It's important to think about your research question. And if there are comparison groups, what are the groups that you're thinking about? Because those groups would actually serve as an independent variable, a non-manipulated one, and it's going to impact the design you ultimately choose. Any questions about this one? Okay. So when we look at factorial designs, visuals are really important for helping us interpret the results. Usually we're looking at 2 types of graphs. We're either looking at a bar graph or a line graph. So here in the top, what you see are the bar graphs of, this is, I think, driving ability and whether or not somebody's using a cell phone. So when we look at a bar graph, we represent the information in 2 ways. We represent it by color, right? Because we're talking about 2 independent variables. So blue here is no cell phone. And then the burgundy is with a cell phone use. Then we also look at the bars themselves. So the bars represent the time of day. It's up to you as a researcher which independent variable you want to represent as color and which one you want to represent as in the bar component. The dependent variable will always be on the x-axis. Y-axis. X-axis is the independent variable, y-axis is vertical, and that's the dependent variable. So what we have there is driving performance. How well do they drive? Just looking visually at this graph, you can see that the no cell phone people drove better than the people who drove with a cell phone, regardless of the day or night. Another way we represent the information could be in a line graph. So in the bottom one, it's a different study, and its psychotherapy length is the independent variable, and then its personality type. So type A is the blue line with the dots, and type B is the dotted line with the squares, right? And so on the dependent variable, it's number of symptoms they exhibit. So as you can see here, type A personalities, the longer they were in therapy, the fewer symptoms they demonstrated, whereas type B didn't seem to be as affected as much. And in fact, it actually went kind of reversed at the end. So these are different ways that we could graph the information that we're getting, and the visuals really help us understand if there is any kind of, what kind of effects are happening. And we'll look at the meaning. So there are 3 types of effects that we need to look at when we have a factorial design. First one are main effects. Second one are interaction effects. And then the third one are simple effects. So to make it easier, we're going to talk about a case study, right? Because then it's not generalizations, it's something specific, and I'll give you numbers to help you understand as well. So let's say we have 2 studies. And these studies, 2 separate studies, they're looking at the effects of studying on text, text printed on paper versus text on a screen. So all the participants were given a multiple choice test, and then we just wanted to see what would happen depending on the modality. So in study A, the researchers gave them a fixed amount of time. So maybe they said, you have 1 hour to study this material, and then we're going to test you. So one group studied the material on paper. The second group studied it from a monitor, from a screen. In the second study, they looked at how well these people did, but they enabled the participants to take as long as they wanted before the test. So it's self-regulated. So again, people studied either on paper or on the screen, but in study B, they were allowed to take as long as they want before they took the exam. In the results, in study A, there was no difference. So when the researchers fixed the time, in other words, when researchers said, okay, you have 1 hour to study and then we're going to test you, there was absolutely no difference in performance between those who studied on paper and those who studied on a screen. However, in study B, it seemed that when people were able to take as long as they want, those who studied on paper did much better. The performance was worse for screen users. So now, that's kind of inefficient. 2 different studies, same idea, looking at study modality. Instead of having 2 different studies, it would be much more efficient to combine them into one study. And that's where we get a factorial design. So this study, if we put them together, would be a 2x2 factorial design. And the way we usually pose it is that 2, and then we indicate the variable and the levels. Control of study time, and the levels are fixed or self-regulated. That's independent variable 1. Independent variable 2 is the modality, all right? Presentation mode. Levels are on screen or on paper. So this is one way that we represent a factorial design. The dependent variable, remember, is what we are measuring. So what are we measuring here? We're measuring how well they did on that test, right? So their performance on multiple choice tests. So let's look at some results so we can determine what main effects are. So a main effect is simply the overall effect of one independent variable on the dependent variable. Remember, there are 2 independent variables here. We're looking at the presentation mode, and we're looking at the time, whether it was fixed or self-regulated, right? So if we had some data, what we want to do is take a look. Since it's an overall effect, the numbers we will look at are averaged over the levels of the independent variable. So we're not looking at just level 1, fixed, and then self-regulated, and then level 2, right? We're not looking at those separately. We're looking at the average of how that time affected their performance. So each independent variable will have its own main effect. So here's some data. On the top, you'll see is the modality, on paper or on screen. That's one independent variable. On the side is another independent variable, which is the time, either fixed time or self-regulated time. Remember, when we're looking at main effects, we are taking the average of the two. So if we look at the main effect of paper, right, we take the result of fixed time 22 plus self-regulated time is 18. So these are their scores, and we take the average. So the overall average of how people did on the test when they took it on paper was 20. Now let's look at what is their overall average on screen. We average out how they did on when it was fixed time, which is 18, and when it was self-regulated, which is 14, and the overall average is 16. So we can see the overall average when people took it on paper is higher than the overall average when they took it, when they read it on screen, right? When they read the materials on a screen. So now we can say there is a main effect of modality, because we see that there is a higher score when people studied from paper than when they studied from screen. Okay, that's one independent variable. Now let's look at the second independent variable, whether or not it made a difference if the time was fixed by the researchers or it was self-regulated. Now let's see, if they studied the material from paper, the average score is 22. If they studied the score on screen, now we're going across, right? The average score is 18. So the overall average, when time was fixed by the researchers, it was 20. Now let's look at self-regulated time. On paper, the average score was 18. On screen, the average score was 14. So overall, the average score when it was self-regulated was 16. So we can see that the averages are different. On average, overall, when the timing was fixed, they did better than those who were self-regulated, because those who had the fixed time by the researchers scored an average of 20, and those who self-regulated how long they got to study, their average score was 16. So now you could say there was a main effect of modality and a main effect of time, right? So that's what we mean by main effects. How would we represent them? Oops. Okay. So in a bar graph, this is how it would look. Remember, the color, right, represents the modality. So orange is on paper and green is on screen. On the left, the dependent variable, we are marking off the performance score. So we saw this is just simply a representation of that data that we saw in the table. So fixed time, remember, they scored higher regardless of whether it was on paper or on screen. So you can see the orange bars are higher than the green bars. That's why we know there is a main effect of the modality. In terms of the time, there is also a main effect of that, and that's why you see the orange colors and the green colors are also consistently, the orange bars are higher than the green bars. So in color, it makes a difference, and also in the bar, it shows. So there are two main effects for this particular study. Now let's look at how it would look on a line graph. So in a line graph, now what you're doing is you're basically putting a dot where the values would be, and then you simply draw a line across. So you can see, again, fixed time, the score was on average higher. There's a main effect of whether or not the time was fixed, and there was also a main effect of whether the study was happening on paper or on screen. Why? Because on paper, the scores are higher. You can see that by the positioning of the dots on the first part of it. Those scores are higher than the ones that are on screen. Same thing here. Let's go look at the bar graph again. The scores on paper in orange are higher than on screen. And also, if you look at the fixed time, those scores are higher than the self-regulated time. So that's how you know there are main effects for both independent variables. Now let's look at interaction effects. This is what makes factorial designs so significant, because only a factorial design can show us what the interaction is when we look at both variables together, right? So an interaction effect is when the effect of one independent variable depends on the level of the other independent variable. It's not just consistent, it happens with an interaction, right? So usually it's more important than the main effects. Interaction is an it depends situation. For example, if your friend said, hey, let's go watch a movie together, if your answer was sure, that's a main effect of the friendship, that you don't even care what movie it is, you're just going to go watch it. Now, on the other hand, if you say, well, it depends on what movie you're going to watch, that is an interaction effect. So yes, you enjoy your friend's companionship, but it depends on what movie you're going to see before you spend time with them in that way. That's an example of an interaction. So let's look. If we were going to look at these effects, how would it change? Again, let's look at the modality first. On paper, right, they study from the material on paper and the time is fixed by the researchers, the average score is 20. Now let's look on screen. If they studied from a screen and the time is fixed by the researcher and the average score was still 20, the overall average is 20. Now we're looking, by the way, at the specific levels. If we're doing it on paper in self-regulated time and their average score was 20, right? Then we know on paper, right? It's not really making a difference. It's the same score both ways. On screen, let's take a look. If their fixed time is average is 20, and then on self-regulated time it's 14, there is a difference now, right? There is a difference between the on paper and on screen. We see that there is that effect. On paper, they had a higher score than on the screen. Now let's look at the time regulations. If it's fixed and they studied it on paper, score is 20. If it's fixed and they studied on screen, average score is 20, no difference. If they had it self-regulated on paper, the average is still 20, but on screen, their self-regulated score was only 14. That is where we have the interaction effect, right? So in other words, the effect of whether or not it was self-regulated only happened when when people studied it from a screen. Otherwise, it was the same in everything. That's the it depends component. The screen modality was only affected their scores on the multiple choice test if people were allowed to spend as long as they wanted. That's the only time the average scores changed. If you look at inside the green boxes, the average score on the multiple choice test was consistent all the way across. The only time it changed was when the screen modality intersected with the self-regulated time component. That is an interaction effect. How would it look on the bars? In a bar graph, this is how it would look. Everything is pretty much equal except for one bar. That's how it would look in a bar graph, right? That's how you know it's an it depends situation. So there was no difference in terms of being fixed time. You can see the bars are equal here. And then on self-regulated time, the only time it dropped was when it was an on-screen modality. That's an example of interaction effect. How does it look on a bar graph? Here, there is actually, you're going to see an intersection. So if you recall, with the main effects, the lines were parallel because the lines were consistent. The effects were main. It didn't matter on the level. In every level, there was still an effect. For an interaction effect, you're going to see the lines cross over because of that it depends situation. So that's an easy way to see it. If you see on a graph, on a line graph, that the lines are intersecting, right away, you should know, oh, there was an interaction effect that occurred. Which one had the interaction? Well, as you can see, where does it suddenly drop? So for fixed time, the line is perfectly horizontal. There was no difference. It didn't make a difference in their scores. Where was there a change? When you had self-regulated time, that's when you had the interaction with the study modality, whether it was on paper or on screen. That diagonal, the diagonal line tells you that there was a difference that happened, right? The fact that it intersects with the other independent variable, that tells you that it wasn't a main effect, it was an interaction effect that occurred. All right, so now that you know there's an interaction effect, you have to look at the simple effects. So simple effects are only important to look at if there is an interaction. A simple effect will tell you where the change happened, right? So a simple effect is simply the breakdown of that interaction effect. It is the effect of one independent variable on one level of the second independent variable. So when we talk about, remember when we were looking at main effects, we were looking at 4 different quadrants. For simple effects, we're examining it one at a time. So now let's look. Simple effect of presentation mode on self-regulated time. So that's all we're looking at, right? Self-regulated time. When people studied it on paper, score was 20. When they studied it on screen, the score was 14. So overall, in terms of the self-regulated time, we had the average of 16, right? So right here, we see there is a difference. In self-regulated time, there was a difference in modality. So that's one simple effect that we found. Now let's look at the effect of presentation mode on fixed time. Just looking at fixed time, was there a difference in terms of their scores when they studied it on paper or on screen? Well, on paper, the average is 20. On screen, the average is of 20 as well. So there was no effect at all of presentation mode when the time was fixed by the researchers. So right here, you see there is that interaction that it only mattered. Self-regulated time was affected by the presentation modality. It was not affected in the second component. When we had fixed time, when the researchers gave them a certain amount of time to study, the modality did not matter. So now we know that's one simple effect. Now let's break it down the other way. Now we're going to look at the simple effect of the control of study time on the paper mode. So what's remaining similar here is the paper modality. When the time was fixed by the researchers, average score is 20. When the time was fixed, when it was decided by the participants, average score was 20. So we see there was no effect of reading the materials on paper, regardless of the time that they had. Now let's look, simple effect of control of study time on the screen mode. So when people studied it from the screen, when the time was fixed by the researcher, they scored a 20. But when they were able to decide for themselves, they scored much lower, and there was the score is 14. So we know that there was a simple effect of the control of study time on the screen mode as well. And those are the 2 simple effects that we had. So the simple effect just helps us to understand. We break down the interaction. Where was the level that the modality affected the score? Was it, so we go back here, was it because it was the version of whether they studied on paper or on screen? Well, yes, there was a simple effect of the screen modality when people got to study it, when they regulated how much time they had to study. So there's a simple effect there. And then when we looked at the modality component, here it's also confirmed. When we broke it down, the screen modality was only affected when it was self-regulated time. So those are the simple effects that we looked at. That is that interaction. We broke down those 4 quadrants into just 2 quadrants at a time based on the independent variable that we were examining. So how does this look in a bar graph? Well, now in a bar graph, it's going to be a simple bar graph. Right? So here is a representation of the data. Fixed time, on paper, on screen, same score, no effect. But when we looked at self-regulated time, you'll see that the screen scores are lower than the paper scores. So when we were looking at the entire study together, right, remember we combined it. We looked at the orange and green bars in conjunction. When we look at simple effects, we're only looking at one level of each independent variable at a time. That's why it's called simple effects. So here is the bar graph when we looked at it, depending on the modality. On paper, there was no difference, fixed time, self-regulated. On screen, however, we did see a difference that self-regulated scores were lower than the fixed time scores. How does it look on the bar graph, on the line graph, sorry? Fixed time is going to be a straight line because it didn't make a difference. But self-regulated time, we're going to see the diagonal. When there's a diagonal, then you know there is an interaction effect. So you can see that the paper scores are higher than the screen scores only in the self-regulated time condition. Let's look at it on paper. Again, on paper, horizontal, perfectly straight horizontal line, then there was no difference whether if they studied it on paper, whether they had fixed time or self-regulated time, didn't make a difference. Screen only made a difference when it was self-regulated. So this is consistent with what we saw here. Okay. All right, so what do these results mean? Right? We're looking at this bar graph. If you're looking at this, remember, you look at the colors and you look at the bars separately. Day, what's happening in the day? Is there a difference whether people use the cell phone or not during the day? Well, the bar graphs, the lines are different. So it looks like people who use their cell phone performed worse than those who did not have a cell phone during the day. Now let's look at night. Well, same thing. People who use their cell phone at night, which is the red bar, did worse than those who did not have a cell phone at night. So you know, looking at time of day, the scores in the time of day are higher than the scores time of night. So there's a main effect of time of day. The bars, the colored bars, have different lengths, have different heights. So you also know that the use of cell phone was also an important main effect. So that's what you know from those results. What is not as obvious in the bar graph, but is really obvious in the line graph, right, is if there is an interaction effect. It's much easier to see it in a line graph. So in the bottom line, we are looking at psychotherapy length, right? That's the independent variable. And the dependent variable is number of symptoms. So the two different independent variables in the bottom part are personality type, which is type A, type B, and we're looking at psychotherapy length. What you see here is that the lines are intersecting. What does that mean? It means that there is an interaction effect that's going on. So anytime that you see that interaction, so there's an interaction between the personality type and the length of psychotherapy. With the personality type A, actually, their symptoms dropped consistently in comparison to the type B personalities. That's the interaction effect. All right, so why would we use a factorial design? It is more complicated, but it actually sheds a lot more light on the human condition than a design that only has one independent variable. So it enables the study of more complex situations. It's more efficient than conducting multiple experiments with the same dependent variable, right? Also, it helps you to examine the overall effects of multiple independent variables at the same time because you have the two different ones. So that's why it's efficient. It gives you information about how each factor individually affects the dependent variable. And it's the only kind of study that also helps you understand how factors jointly affect the dependent variable. Without a factorial design, you cannot study interaction effects because you're not seeing them at the same time, right? So it's the only design that allows for the observation of interaction effects. If your study question, if your research question has to do with an independent variable like race or ethnicity, and you want to look at, maybe depression levels, or sorry, that's the dependent variable. Maybe you're looking at the race and ethnicity and socioeconomic status, for example. Those are two independent variables that you could study, and maybe your dependent variable is depression. So only an interaction, only a factorial design can look at those two in combination together. If you're doing a straight experiment with only one independent variable, then you can't combine the two. You'd have to do one study that is just on maybe race or ethnicity. So maybe you'd have different comparison groups. And then you'd have to do a separate study that's on socioeconomic status. So, you know, lower class, middle class, and upper class. So you can only combine those two in a factorial design experiment. If your research question is interested in comparing that, then it has to be a factorial design. But you have to be specific when you tell me, is it going to be factorial design survey, factorial design experiment, factorial design naturalistic observation? So you just have to let me know if you're going to be studying more than one independent variable. So it's useful for expansion and replication of previous studies because you can start adding levels, right? So that's why, for example, if you were interested in doing a replication of the Stanford prison experiment, in the Stanford prison experiment, they made a point of having a very homogeneous participant group. They chose all white males, same age. They made sure that psychologically they had the same profile, same socioeconomic status. They did that to rule out alternative explanations. Now, let's say you want to do a replication and you're saying, I want to study Asian males to see if Asian males would react the same way. But to expand it even more, I want to look at Asian males and females. So now you're looking at a factorial design. You're looking at the effect of gender, or actually sex, right? If you're saying male and female, and the effect of whether they're a prisoner or a guard, right? The roles. So those are the two independent variables that you would be looking at. So only factorial designs can do that interaction component of being male and a guard, being male and a prisoner, or being female and a guard and being female and a prisoner. That's what the power of the factorial design can do. It can look at that interaction component. It enables the evaluation of order effects in within subjects designs because you're looking at it together, the morning, afternoon, evening component. Increases external validity, absolutely. You're actually accounting for, within subjects design, you're accounting for any individual differences. In a between subjects design, you're keeping them separate. But because you're doing it this way, in one study, you're actually increasing the external validity of the study. What's the disadvantage to factorial designs? The more independent variables you add, the more levels you have, the more complex it becomes. You need more participants, and starting to do the different conditions and actually running the study becomes much more complex with the factorial design. So I do not recommend you go more than 3 factors. In fact, most studies will just go 2 factors in terms of their complexity. So identifying a factorial design in a study. In a scholarly journal, in a scholarly article, it's very easy because they will explicitly state it's a factorial design. So this is how it might look. They'll use factorial design notation, right? They might say a 3x2 between subjects design varied activity level, and then they indicated it. The levels: intense exercise, moderate exercise, exercise with diet plan, vegan, non-vegan, to examine the effects on subjective well-being. So there you're given the independent variables and the dependent variables. They tell you right up front, it's 3x2. So 2 independent variables, one with 3 levels, the other with 2 levels. And they tell you what they are. They are activity level, that's the first independent variable, and the 3 levels are intense, moderate, and just exercise. And then the second independent variable is the diet. What are the 2 levels? Vegan and non-vegan. What's the dependent variable? Subjective well-being. So whenever you're reading a study, right, the effect of blank and blank, those are your independent variables. Whatever follows the on, that's your dependent variable. That's how you find out in a scholarly article. Another way they might represent it is they'll say the design was a 2, and then in parentheses, they tell you the independent variable and the levels, right? Diet choice, vegan, non-vegan, by 3, and then they tell you the variable is activity level, and then they list the 3 different levels, and factorial design, they go on. So in the scholarly article, very easy to tell if it's factorial design, because they'll explicitly state the independent variable and the levels involved, right? In the results section, you're going to see a discussion of whether there were main effects, interaction effects, and if there are interaction effects, they'll talk about the simple effects as well. So very easy to identify in a scholarly article. It's trickier in a non-scholarly article because, remember, non-scholarly articles are designed for people who are not experts. They're designed for the general public. The general public will not be able to follow this whole factorial design notation component. So how would they state it? It would be, they would state it in a way that shows it's an it depends situation, right? So it's more likely they're going to describe the conditions. So one study looked at the effects of exercise and meals on people's levels of exercise activity and followed different diet plans. So in that first sentence, right, effects of exercise and meals, right there, two different independent variables, right, on people's sense of well-being. There's your dependent variable right there. People were engaged in different levels of exercise activity and followed different diet plans. The researchers found that overall, 48% of people who engaged in moderate exercise and followed a vegan diet felt better than people who didn't exercise and followed non-vegan diets. That's your interaction. It's an it depends. What did it depend on? The level was moderate exercise and followed a vegan diet plan. It didn't happen for everybody. What they're saying here in layman's terms in a non-scholarly article is that there was an interaction effect. It only helped their well-being if it was moderate exercise and they followed a vegan diet plan. That's your interaction effect. Those people felt better than those who didn't exercise and followed non-vegan diets. So you didn't see an effect in the other conditions. So with a non-scholarly article, it is much trickier to determine if it was a factorial design. When you're reading it, you simply have to look for that it depends component. And they might even say it depended on how much exercise they did and how much and what they ate. So that's how you know in a non-scholarly article. And I believe that's it. Okay, so let me go ahead and stop the recording and we can answer any questions.